Hi, it's Mrs. Tellas. So I'm off today, and you are watching this video so you can complete the first little worksheet, and then you'll have a second. You'll have a second video and a second big ideas assignment. So this is just the first worksheet. So here we go. We're going to talk about tables today, and we're also going to talk about exponential growth and decay. All right, so a quick little review from middle school. To change a percent to a decimal, you may either move the decimal 2 places forward, like 1, 2, okay, or you can take your 7 and divide it by 100, and that will give you the same 0.07. Okay, so press pause and give these a try. Make sure you know how to change them to a decimal. So this one would be 0.12. This is 0.85 and 0.8. Okay, so you have to be able to take a percent and change it to the decimal in the formulas. All right, so exponential growth function is here. Y equals A times the quantity, 1 plus R raised to the T. So A is your initial amount. You're going to want to write this down for growth. It's your initial amount. R is your rate of growth. It's going to tell you that. The whole thing inside the parenthesis is called the growth factor, and T is time. Okay, and then Y is your answer or your final amount. So once you have that information, you should be able to them give you pieces and you plug them in and write the exponential growth function. Notice that the growth function has a plus sign. All right, and so the opposite of that would be the exponential decay function. Okay, so again, Y is our final amount, just like it was for exponential growth. A is our initial amount, again, just like it was. R is our rate expressed as a decimal. T is time, and this is our growth rate here, or our decay rate, honestly. The only difference between the two formulas is this minus sign. So when it's a decay, inside the parentheses will be less than 1, and when it's a growth, inside the parentheses will be more than 1. Okay? All right, so determine whether each function represents growth or decay. Well, we do that by looking inside the parentheses. So I look at the parenthesis in here, and first of all, there's a plus sign. So since there is a plus sign, this is a growth equation, an exponential growth equation. And if I identify the percent rate of change, I look at this piece right here, and I change it to a percent. So if I have 0.09 and I want to make that percent, I can either multiply by 100, or I can take 0.09 and move the decimal over twice. So it has a growth rate of 9%. Okay, so it works the same for number 2. You can see that this is a decay function because there's a minus sign in here. So this is exponential decay. And to get my percent rate of change, I look right here. And I move the decimal over twice. So that's 5%. So my rate of change is 5%. 5% decay. All right, and same thing here. Once you press pause and try both of these. So this one would be growth because it's plus, and this one would be decay because it's minus. And this one has a percent growth of 6. And I can change 1/2 to 0.5. So this one has a decay rate of 50%, because if I move it over twice, it's 50%. All right, so your turn. Well, actually, these are a little different because the math is already done inside the parenthesis. So you can see that this one is less than 1 inside the parenthesis. So this is a decay function or an exponential decay. Okay, so if I were trying to get this to be 0.8 and I needed to write 1 minus something, my minus something would be 0.2. So 1 minus 0.2 is 0.8. And you could do that by using your calculator. 1 minus 0.8 gives you 0.2. So your percent rate is the 0.2 or 20%. 1, 2. And same thing on the next one. This is less than 0, so this is a decay. Okay, and again, I'm going to do 1 minus 0.90. What's 1 minus 0.95 is 0.05. So my decay rate is 5%. So I'm just taking this and subtracting 1. 1 minus that. That will give it to me. And then this one's a growth because it's greater than 1. 1.06 is greater than 1. So it's going to be 1 plus, well, we can tell very easily that 1 plus 0.06 is this. So my percent is 6%. And 5 over 4, I'm going to convert that to a decimal, which would be 1.25. So this is greater than 1, so it's a growth. So 1 plus 0.25, so it's 25% growth rate. Okay, so I want to break this up so it's like the initial equation where it's 1 plus the rate, 1 plus r, and I'm just looking for the r. And if it's a fraction, you got to go decimal because you can't change a fraction to a percent without changing it to a decimal first. All right, and then the other thing you have to do is determine whether the table is exponential growth, or exponential decay, or neither. And by neither, it's probably going to be linear. So we'll look. Okay, so remember, exponential tables have a multiply pattern of some kind. Okay, a multiply, or it could even be a divide pattern. So if I look here at my relationship, I think, okay, this could be divide by 5. But the rest of them have to be that 2. That one is, and that one is 2. And these are all plus 1. So since it has a divide pattern, this is a decay. And I can tell because it has the divide pattern. Okay, and then number 11. So 35 and 29. This looks like it's going down by 6. It is. This goes up by 1. This is linear. So it's not, we don't want linear. It said growth, decay, or neither. So this is neither. But if we wanted to go a step further, it is linear. It has a slope of negative 6 over 1. And if I look down here, this one, I could add 6, but that's definitely not add 6. So let's try multiply 4. See if that pattern works. And it totally does. Okay, so this is an exponential growth because there's a multiply pattern of multiply by 4. Up here, we're adding 5. Okay, so it's that y that determines whether it is exponential, whether there's a multiply pattern, that would be growth, or a divide pattern, which would be decay. You try the even ones over there and see if you can come up with them. So press pause and give them a try, please. So it looks like this first one, if you tried it, looks like we're dividing by 4 for all of them. So this is a decay. And it's a decay because our pattern is divide 4 on the y. And 12 looks like we're adding 2. This is linear, so I'm going to put neither. It has a slope of 2 over 1. And then my last one, my picture's kind of in the way. Let's move it. So looks like we're multiplying by 2 here. Multiply 2, multiply 2, multiply 2. Yep. So that's a growth pattern. And I know that because my pattern on the y is times 2. Okay? All right. So you're going to stop here and do the worksheet number 1 for 6.4. It's on Canvas. I also attached a key so you could check it to make sure it's right. When you're done, take a picture of your work and submit it on Canvas to get credit. Thanks. Have a good day.